Ever wondered how to determine the concentration of an unknown metal ion in a solution? Well, one of the most effective methods to do so is through a process known as complexometric titration. This fascinating process involves the formation of a complex ion between a metal ion and a ligand. The ligand, often a multidentate molecule called EDTA, forms a stable complex with the metal ion, allowing us to determine the concentration of the metal ion. To understand how this works, imagine a dance. The metal ion is the dancer, waiting on the dance floor. The ligand, or EDTA, is the dance partner who comes in and forms a complex, or a dance, with the metal ion. The process starts with preparing the sample solution, which contains the unknown metal ion. Then, the indicator is added. The indicator forms a weak complex with the metal ion, creating a colorful solution. This color change signals that the dance is about to begin. Next, the EDTA solution is slowly added. As the EDTA is added, it forms a stronger complex with the metal ion, outcompeting the indicator. This is like the dancer choosing a better dance partner. As the EDTA forms a complex with the metal ions, the color of the solution changes, indicating that the EDTA is now the dominant dance partner. The titration continues until all the metal ions have formed a complex with the EDTA. This point is known as the end point, and it's where the color of the solution changes again, indicating that all the dancers have found their partners. It's important to note that the strength of the complex formed between the EDTA and the metal ion is influenced by the pH of the solution. Adjusting the pH can help ensure that the EDTA forms a strong complex with the metal ion, leading to a more accurate titration. So, what have we learned today? Complexometric titration is a powerful tool for determining the concentration of an unknown metal ion in a solution. It involves the formation of a complex ion between the metal ion and a ligand, often EDTA. The process starts with preparing the sample solution and adding the indicator. The titration continues with the slow addition of the EDTA solution until all the metal ions have formed a complex, and the endpoint is reached. It's a dance of chemistry that reveals the hidden details of our sample solution. And remember, like in any good dance, the key to a successful complexometric titration is balance. The right pH, the right indicator, and the right amount of EDTA all contribute to a successful titration. So the next time you're wondering about the concentration of a metal ion in a solution, remember the dance of complexometric titration. It's a dance that reveals the hidden secrets of our chemical world.